Okay, assuming, and here's the important part, Danielle, that you were asking about. Assuming that these ages constitute an entire population, find the standard deviation of the population. All right, now let me just show you that formula. And this is when you've got a population, you don't do the subtraction. So I'm going to write it over here.
Wait, Mr. Cruz, you said when you got the population, what? Your voice cut off.
You don't subtract the 1. I'm going to write it right here. Okay, okay, let me, just give me a minute to write this down, and then I'll switch over where you can see it. But we're going to look at that problem right there, or at least how to set it up. All right. Let me switch over here. All right. So, wrong one. I wanted to go over to the board. All right. What's going on here? I think it's just incredibly slow today. All right. So give me a second to switch it over here to the board. I'll go ahead and write this while I'm waiting. All right, so should be up there in a second. This little thing right here, that's what they call the population standard deviation symbol. It's a sigma. It just looks like a kicked over 6. It's a Greek symbol. Well, anyway, for population, when you've got a population, then you do not do, there's no subtraction down there, no -1. So therefore, let me go back over and grab that problem. All right, so I'm going to stick the problem in here. All right, so notice the wording of this problem. I mean, this part up here is not so important. It just tells you that you got 6 people and their ages. But here's the important part. This is where it tells us what's important. We've got a population here. Therefore, this is what we use right here. So I'll just kind of sum this up.
Mr. Cruz, quick question.
Mm-hmm.
So if they have a population, we use that formula, right? But
Mm-hmm.
say if they didn't have the population, what do we do?
You use the sample standard deviation.
Okay.
That's the other one, because that was the original question that Daniel had about when to subtract one and when to not.
Gotcha.
Okay. All right. So let's just go through it since we already brought it up. Okay. So first thing we got to first find the mean. But let's put that right here. For any population, no matter what kind of standard deviation it is, we first have to have the mean. All right. So over here, they usually call it this. It's mu, but it's the same thing for whether it's a population or not. As far as calculation, they just have the different name for it, the different symbol. So what we're going to do is 30, and y'all help me calculate this. Add all these up. By the time I get them written down, y'all tell me what these add up to. Okay, did I write them all down right?
Yeah, it comes up to 198.
Okay, oops. That's divided by 6 because the 6 is in. So here we just say n is 6. It's just the number of pieces of data right there. So it says 198.
Yeah.
And then if we divide by 6, I'm hoping we're going to come out with a whole number. And it sure does, 33.
Mr.
Now,
Cruz, it came out with, if it didn't come out with a whole number, it would be wrong.
you're going to have to
right?
round it off, and it ends up being a little bit bigger headache. That's all there is to it.
Gotcha.
I mean, there's no law that says it has to come out to a whole number. It's just that I think most of these should come out to a whole number. Like I said, it makes them a whole lot easier if they do. Now, I'm going to show it slightly different than the way that the ALEKS shows it, because I think the ALEKS can be confusing, because they do it in a horizontal way and they do it with parentheses, and you don't get to see the individual process. I'm just going to write down these numbers, all of them, and I'm going to write them in a column. All right, and that's what we call X. All right, now we got our mean is going to be this, and we're going to subtract 33 from everything, or each one, not everything so much as each one of them. And what this essentially does is it just tells us how much more or how much less each one of these are than the mean. So X minus mu is going to, what we're going to put here. So this is going to be -3. This is 7, right? Negative. This is negative 9. This is 12. Positive. So this one is 8 negative. And this one's 13. Now make sure I got all those right, because if we don't, well, here's how you can tell if they are right, or how we can tell if we've done everything right up to this point. If we've calculated the mean correctly, and if we've done those subtractions correctly, all of these right here will add up to what? Somebody out there knows, I know that.
0.
Yeah. And this happens for all the standard deviations. So notice that we've got some that are positive and some that are negative. All right, I did these by my head, so I'm gonna go back through because I don't think they're right. I don't think 27 minus 33 is right. Yeah, it's minus 6. Okay, now that's it. So see, you can easily make a mistake, and this is why that's important, to be able to add them up and see if they're right. Now, if you add up all the negatives, you get 19, you get 25 negative. And then if you add up the positives, you get 25 positives. So the sums is equal to 0. If they don't, then something's wrong. And that was the one that I did, and I didn't do it with a calculator. I did it in my head real quick, and it's easy to make a mistake like that. So, yeah, thanks, Kenya. But that's why that's a mid checkpoint, because you're not going to always have somebody to tell you, looking over when you're doing your homework or when you're doing tests. So that's why you get that little checkpoint. Now we're going to do the x minus mu squared. And that's the last of the hard stuff. We're just going to square each one of these numbers. And the number, when it's squared, is always going to be positive, no matter whether it's a negative or a positive. So negative 3 squared is 9. Negative 7 squared is 49. Negative 9 squared is 81. Negative squared, 6 squared is 36. And 13 is 169, I believe. All right. Now we got to add all these up. The sum of the squares. In other words, that's what this up here in the numerator means. It's the summation of all these squares. So I'm going to go through and do them. 69 plus 144. I'm going to do the big ones first. I'm going to do them by size. And it looks like they come out to 488. Is that right? Somebody double check for me. $488. Okay, that's the numerator here. So this population standard deviation is equal to 488 over 6. And it's 6 because this is the population. All right. So then this is going to be, it says approximate to 2 decimal places. So I got the little squiggly thing there. So we got to go out to actually, you know something, I think that little, this thing right here, let me share the whole screen. Probably ought to get in the habit of doing this more, so I don't have to keep going back and forth. All right, so this has got that little calculator on here. Now it doesn't have a function for the mean or the standard deviation. So these are the two you got to do by hand. But it does have, remember the ones we talking about for the last chapter, and then you're going to see for the last stuff in chapter 11, you got that little thing. I showed you before about it, but we got this calculator here. But anyway, so it was square root of 488 divided by 6. So that gives us 9.02. There we go. 9.02. So that's what we're looking for, and that's what we put in here. Okay. So any questions about that? I'm going to go back and do the one before it, which is the one we have to subtract.
No, Mr. Cruz, thank you. You answered my question.
All right, but I'm going to do this one now, just because you know.
Yeah.
We got to
So
get
I
the
can
full
see how
lesson
that
here.
works as well. Thank you.
All right. So now, all right, I'm going to put this one over there on that board, and we're going to go through the same process, and I want to make sure that everybody understands it, because Danielle, you had a question about it, but so there's other people out there that will too. Okay, this is still the N is 6. Now notice that the red blood cell counts of a healthy adult measured on 6 days are as follows. So there's still 6, but here's the key thing that makes this one different. This is a sample. What that essentially means is, for that other one, it was talking about the ages of an employee. So that was like everybody that worked in the store. This is more like this person is getting their red blood cells counted every day for, a month. And we go out and we get a random sample of 6 of those to compensate, because we don't know all of the data. Then we use the sample standard deviation. Okay, so here's the difference. besides it just being just a little bit, like I said, they usually call this S, so you can tell the difference. Up in the numerator is exactly the same. Now over here, when you're talking about the sample, this is generally called X bar. It's calculated the exact same way, so you don't have to worry about it. But that's what they call the mean when you deal with a sample. Just like when you call in the sample standard deviation, you call it S. Now here's the big difference. N minus 1. All right, so we're going to put here N is equal to 6. All right. And then we're going to say the mean is equal to, and I'm just going to put that little symbol X bar. And then we're just going to add them all up and divide by 6. No matter whether you're dealing with the population or the sample, for the mean, the calculation is exactly the same. The only thing that's different is that second to last step, or that last step before you take your square root on the standard deviation. Okay, so let's make sure I got them right. 53 plus 48 plus 51 plus 52 plus 49 plus 53. So what do those add up to? 53, you know what? I'm gonna just try to have it using this little calculator. So it's 306. So what does that come out to? So 51. All right, so here everything exactly the same so far. We just got to remember this is a sample, because when we get down to doing that second to last step, we're going to divide by 1 less. And as I had said, if you didn't hear it, the way that Alex shows this, I don't really care for it. It's like it shows it horizontally, and they'll put the X minus kind of thing in there. But you end up missing out on seeing one of the steps, at least, as I remember. So this is what we call X. And this is X bar. So it's going to be 51 all the way down. All right, so we're going to subtract this. And then this column here is going to be X minus the X bar. It's going to be what it's also called the deviations. I don't know if they ever tell you that. It doesn't really matter that you know that, but that's what it's called. It just how much of difference there is between the mean and each one of the numbers. So this is 2. This is -2, 0, 1. Oops, this is -3. This is -2. And this is 2. So now if you calculate these out, if you add these up, -3 and -5, I'm sorry, -3 and -2 is -5. And then 2, 1, and 2 is +5. So you know you got right because those add up to 0. If we did this and we did this subtraction right, then we're clear up to that point. So the last major step is to square each one of these, and they will always be positive because any number squared is always positive, because whether it's 3 or -3, it's going to be two negative, either for negative times negative, it's two negative signs that gives you a positive. And if it's positive, of course, it's going to be positive. And this is the reason, one reason why this happens is because we don't want any negative numbers underneath that square root. All right, so 12. So it looks like that's 22, right? Double check for me. Yep, 22. So this is the summation of that squares. Oops, I forgot to put that there. It's that top part. That's your numerator right there. So there's a 22 in the numerator. And then down here, it's 6 minus 1 because it's a sample. And these right here, there's no way. I mean, you might be able to get them to come out to be a whole number, but I don't know if I've ever seen it, because square roots are almost always going to be, irrational numbers. They're going to have to be approximated. So, so so we're going out to 2 decimal places, so it's 2.10. Okay. And that's what goes in here. All right, any questions about the standard deviation before we start going back to the other stuff? That's really probably the hardest stuff in the whole chapter. So, all right, well, we'll go back now and just kind of start from the beginning. All right, so this is just asking us to do a frequency distribution. They try to make them fairly small, but this is what we call a class width of 6. They've only got 3 classes. Usually, in real life, you got at least 5 classes, but, they try to make them small so they're not too time consuming for you. But anyway, what we got to essentially do is we got to go through here and we got to find how many there are between 15 and 20. Now, it's important to realize that there are 6 values in there. If you count, you got 15, 16, 17, 18, 19, and 20. Whoops. What did I do wrong? 15, 16, 17, 18, 19. So that's 9, and then an extra one. So that's the 6. All right. So it's not between there. It includes 15 and 20. So none of these up there are in there. Here's one. 16 is in there. And so also is 15 and 19. So 16, 15, and 19 are in there. So there's 3 of them in that range right there. Now the next one is 21 through 26. That's actually all 3 of these. 3, and then also this one. So there's 4 of them. And there's 1, 2, 3. So there's 9 of them. So there should be 2 more. So we got 27 to 32. So there's 1 and there's 1. And there's the other 2. All right, did I get them all right? Because the frequencies, when you've got them all done, you should be able to add them up so that you have exactly the number that there are in the original data set. They don't tell us how many there are, but if you got 3 rows and 3 columns, 3 times 3 is 9 of them. You can also count them like that. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Well, Mr. Cruz,
Mm-hmm.
even though if they have 28 twice, you have to include it twice, right?
Yeah, because there's
Okay.
22 of them.
Okay.
Because if you just put it in there once, then what's going to happen?
It's not gonna.
It's not going to add up.
Yeah.
You've got to include that twice.
Gotcha.
That's an important data thing. If what is this? This is a shopping time. But let's just say you were recording something like pulses per minute, for heart rate. You're probably going to have a lot of them that are the same because the heart range, heartbeats for a human being, they're all going to fall in a fairly tight range. So you're going to have plenty of them that are going to be the same probably. So you just have to tell how many, because then that will tell you, then you'll be able to figure out the mode if something repeats. See, in this case right here with this data set, the only one that repeats is the 28. So if we were also calculating the mode on this, we can see that the mode would be 28 because that's the one that repeats the most. All right, here's another one. This is what they call it non-grouped. And they call it non-grouped because you don't have to do the grouping because the groups already exist. Because these are cell phone models A, B, C, and D. All right. And there's not going to be any values in between like it was for the numbers. Here, the values are going to fall naturally into one of those 4 categories. So I'm going to go through, and you watch me and make sure I don't make a mistake, because I'm going to count the number of A's first.
Comes
So
up to
1, 2,
it comes up to 6.
3, 4, 5, 6, and you're right. There's 6 of them. There's 2 here, 2 on that row, and 2 on that row. So 6 of them. Now let's calculate the B's. There's none on the first row. There's 2 on the second, and there's 2 on the third. So there's 4. Is that right?
Yes, sir.
Okay. And then the number of C's. There's 1, 2, 3 up there. And then there's 2 more here. So that's 5. And then there's 1, 2, 3, 4. So that's 9, right?
Yeah.
And then the number of D's is 1, 2, 3, 4. Is that right? 4 D's? 1, 2, 3, 4.
5.
Where's the 4th one at? So 1, 2, 3. Oh yeah, you're right. 5. I see it. All right, and what do those add up to? See, that's 10, 19, 24. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So there's 24. So because 8 times 3 gives you 24. So we got them all. Now this is just asking you to look at the different frequencies, because now they're going to talk about phone plans that you can use with the various models, and they want to know how many are in a particular one. So now you're looking at this, and when you look at this, you're going to have to come back up here and look at this. You don't need to look at this anymore now that you have your frequency distribution. So how many cell phones sold at Tom's Electronics yesterday can use the Horizon plan? Well, the Horizon plan is A and C. A has 6 and C has 9. So that's 15, right? The horizon plan uses model A and C, and A and C, A has 6, C has 9, which is 15. All right. This is a histogram, and I think sometimes you may get a frequency distribution here because, it rotates, but it's very similar. What we got to do is create a frequency distribution like we did in the first one. This time the class width is 5. So anything between 79 and 83 inclusive. So up here, there's 2 of those. So 79 and 81 would go in there. And then you got 1, 2, 3, 4 80s that are in there. And then you got an 83. So 4, 5, 6, 7, it looks like, for that first one. 1, 2, 3, 4, 5, 6, and 7. Now, how many are between 84, 89, and 88 inclusive? We got 85.
That's it. Only 85.
Yeah, it looks like that's the only one, doesn't it? 85 is the only one that's in that range there. There's no 88s, there's no 87s, no 86s, and no 84s. The next one is 89 to 93. So there's an 89, and here's a 93. So we got 2 of them so far. And then here, we got a third one, the 90. And then this is a 4th one and a 5th one. Right? So let's see, we got 1, 2, 3, 1, 2, 3, 4, 5. So there's going to be 15 of these. So 7 and 6 is 13. So we're going to have 2 more somewhere. Well, 2 more for the last column. So let's see if we can find anything 94 to 98. All right. So there's a 95 that's in there.
And the 97 on the first row.
You're right. There we go. All right. So now we got 7, 1, 5, and 2. Now they've already got these marked out for us. I know that somewhere in Alex, and I think that this one may alternate between a histogram and a frequency distribution. If you got a frequency distribution, you got to add up 79 and 83 and divide by 2 and put your midpoint, label your midpoint in there. But for these, they already got it marked out for you. So we're just going to carry this right here. The finger comes up and we're going to take it up to 7 to represent that. The second one is just a 1, so we just go up 1 there. This is the 89 to 93, so we're going up to 5. And 94 to 98 is going to be 2.
So, Cruz, when did you say you would divide? Your voice cut off.
Oh, what you're saying is this is a histogram. You have a frequency distribution that's very similar to this. And the frequency distribution, what they do is they have you put the midpoint here. So the midpoint is, I don't have the other calculators not on here, but 79 plus 83 divided by 2. So 81 would be right in the middle, see? So on the frequency distribution, if you run across one of those, I think that this one will alternate between a histogram and a frequency polygon, I'm sorry. They'll put you'll need the midpoint to put right there, 81. All right, so now we're getting into some more data here. And I would say we could do this all with a calculator, but it's really difficult to do the median with a calculator. So I'm going to do this one, the mean first, and I'm going to use their calculator. So what I'm going to do is 38 plus 77 plus 10 So 468 is the total, just like we did for the standard deviation when we calculated the mean there. Now we're going to divide by 8. And so 58.5. All right, any questions about that? That's just a simple old mean. Now the median, let's see. Let me go back over to the board thing here. We're going to calculate the okay, let's see if I can. All right, so the first one is 10. And then 38. And what would be next? 52. So 10, 38, 52. And then next is 62. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and that looks to be original. All right, now they're sorted smallest to largest. All right. Now, there's no one in the middle here. All right. Here's the problem. See that right there? There's no one in the middle. There are 2 in the middle. So All right, so then now what that's going to be is 62. So that's going to be 130, right? Which is 65, if I'm not mistaken. So this is the median. $65. And you'll notice that what it does when we have an even numbers is it puts a value that's between those two, right smack in the middle between 62 and 68, right there between them. Okay. Was there anything that was repeated on this? I'm not mistaken, I don't think there was anything repeated, was there? Everything was unique. And that's one of the good things about sorting it to do the median is that you can easily see repeated numbers, and there is no repeated numbers. There are no repeated numbers. So, okay, well, 65. So there's 0 modes. There's no modes. It's not that 0 is the mode. There is no mode because there's no repeated values. All of the values are unique.
So, Mr. Cruz,
Mm-hmm.
when would it be 1 mode or 2 mode? When there is like, okay, so like if they had 2 numbers repeated.
Well,
right?
let's go back over to here. This one I was telling you about. All right. No, it must have been the first one. See, like this right here, it had one value that was repeated. It had the 28 that was repeated. That was the only value that repeated. Okay.
Okay.
And it's clearly the one that repeats the most. So the mode here would be 28. Now, let's see if there was something else over here. I don't know if I want to look at this one. Well, this one wouldn't work anyway because there's none that have a tie. If you have any that have a tie, let's see, was there anything? Okay, on this one here, 80 was clearly the mode on this one because it repeated the most. All right.
Yeah.
There was nothing else that repeated that I can see. But if, let's just say, instead of 4 80s, we had 2 80s and 2 82s there. All right. Then that would be 2 modes because the repetitions, the ones that repeat, they have a tie. They essentially don't have one that repeats more than the other.
I get what you're saying now.
Yeah. So there's the 3 possibilities. Either each piece of the data is unique, there is no mode, one repeats more than the others, or the ones that repeat, they have a tie. All right, again, this is a median. Let's say, what's this one over here? All right, we got enough time to do both of these. All right, so this is another median. All right, so $12, $11, $10. All right, so let's just make sure I got them. And then we're going to have to do the same thing. We're going to have to sort. Now, the thing that's different here, I believe, is we got an odd number. So this one's going to be a bit easier. Second 12. Now, this isn't asking for, okay, so 1, 2, 3. All right, I've got them ordered. Okay, but this one isn't asking for the mode, but let me just point something out. You got 2 10s and 2 12s. 2 10s and 2 12s. So this would have two modes, a mode of 10 and a mode of 12. Okay. See, there's one of the modes. There's the other mode. All right, because we're finding the median, so we're going to do the middle number. And we're going to go, there's 9 of them, so there's going to be 4 on each side. And again, you can use this formula, but it's a bit confusing. If it's even, is the problem, because it won't give you a whole number. So this is the so the mode is in the 5th spot, which is okay. And the problem being is if you use this formula over there, like on the even one, I mean, when it's even, you would, I'm sorry, up here. So you would get 8 plus 1, which would be 9. 9 divided by 2 is 4.5. So there is no one. There's no 4.5 position, so it's kind of misleading if you use that. That's why you can't really rely on a formula to do it for median. But if you recognize when it says 4.5 that it means that's in between 4 and 5, then or whatever it comes out to, that the 0.5 just means it's in between left and right of those numbers. All right. So the last one we'll look at today. Because we've gotten about halfway. And I'll leave the rest of them for Thursday. Yeah, this is a good place to go. So let's do number 6. All right. So this is different places. It's in the notes. It's in the Alex. But the range, this is probably the easiest calculation there is to do. But this thing is not really used too much. So it's just to kind of give you an idea about how spread out the data is. Okay, so in this case, you don't have to have them sorted, but they might help you if you wanted to see. So the highest one is definitely 58. And the lowest one seems to be 29, right? Double check that for me. Because like I said, I could sort them and make sure, but so 46, 50, 29, 41, 37, 30, 29, 50, 58 is the highest, and then the lowest is definitely 29. And so 58 minus 29 is 29. So there's your range. All right, any final questions?
All good.
All right then, so let me do one last check on the roster here. See if anybody came in after I did things. So bring your questions on Thursday. We'll go over the second half of that thing.
You have a serious Inception thing going
Really?
with the
What do you-
screen sharing.
Oh, because that's why I don't like doing that share all. Because yeah, I don't know what you call that thing. You know, like if you put a mirror against a mirror.
Yeah.
Yeah, that's why I don't like
Infinity.
using that. But as long as you don't just take it off, if you just keep sharing anything but the main screen, yeah, it works pretty good. Yeah, it's it'll psych you out real quick. So just bring anything you got in on
Can I ask about the
Thursday.
final?
Huh?
Can we ask about the final?
What do you want to know about it? I'll tell you what I know.
All right. Can we take it on a different day, or is the day scheduled? Like, is it going to be a time, or is it set in stone?
No, technically it's supposed to be done on the 2nd, but I'll open it up a day earlier. And here's the thing, and somebody was bringing this up last night, and I thought about this was a problem. somebody was asking me when the Alex learning path was due. Well, what it automatically does is, because I took off the due dates and it puts the due dates at the end of the class, end of the course. So I don't know if it's possible for me to. I know I can go back and extend the date of the course, but if I gotta extend it enough in order for the exam to fit the last day that you would be able to take the exam. All right, so just
I was hoping to take it sooner, basically, as weird as that is. But
yeah, well, what it is, the first day of exams would be the first, and then the second is usually what math exams are. And I was thinking about also opening it up on Thursday as well, perhaps. We might even be able to open it up early, like on Monday. But this is one thing I was going to run past y'all. I maybe was given like a review if you want on that Monday, but I haven't decided what time because nobody's asked about this class, but in my statistics class, I may do it on Monday, so I may do it like on the afternoon or something. It might be a little bit later than this. I'm not sure. Like I might not start till 12 o'clock or something, but I might do an hour and a half review for anybody that's interested. But we'll talk about that on we still got 2 more days. But yeah, you can take it early than the date it's got.
perfect.
Yeah,
Thank you. Have a good day.
All right. Bye-bye.
All right, Mr. Cruz. Have a good day. See you Thursday.
Okay, you too. Bye-bye.
Bye.
All right, bye-bye.